welcome. I'd like to thank you for taking time out of your day to attend this session. This is going to be a session around Heroku and what we offer from an integration standpoint relative to, of course, Salesforce. First of all, I'd like to introduce Troy Sellers. He's with us here all the way from Australia. He's our architect for Heroku in the Asia-Pacific region. My name is Robert Zaire. I'm a product manager. I work on the Salesforce and Heroku broader platform. So I'm responsible for Heroku Connect and most recently platform events and change data capture. So this session will be most useful to you if you have, let's say, either no knowledge of Heroku Connect or maybe some cursory knowledge. If you're already an expert in it, I just want to warn you, we're going to sort of start with the basics and eventually probably work our way to a couple more advanced topics. Everything we show you today is going to be generally available. However, I may on one or two occasions allude to a future feature that isn't in the product today. So please keep that in mind. Obviously, any purchasing decisions should be made based on what's available. Our agenda for today, as I mentioned, we're going to start with the basics, right? So we're just going to have a bit of an overview of Heroku Connect. We'll put that in the context of sort of what Heroku is all up, just in case you're not familiar with that. We'll talk about how it's used, drill into the capabilities and benefits. Again, we're really lucky to have Troy here. He's put together a fantastic demo, and so we'll get fairly deep into how it works, and then we'll leave some time for questions after that. Okay, so these are the data services that we offer within Heroku. I actually want to take a quick step back, and for those who aren't familiar with Heroku, it's a fully managed platform as a service. And the best sort of easiest way to think about it, I think, is there's three pillars of services. So there is compute, so fully managed serverless containers, and Heroku handles the orchestration and the scaling for you. Then there's data services. So we're going to talk about these in a moment. There's 4 of them. They're fully managed. And then there's the ecosystem or a marketplace. And that gives you the opportunity to just, in a matter of a couple clicks or a few lines of code, to integrate things like email services, logging services, application performance monitoring. And then we have a whole tool chain that sits on top of that whether you're an administrator doing billing, a developer, writing the code and wanting to monitor it, or doing sort of ongoing lifecycle operations. So that's sort of Heroku in a nutshell. Heroku data services, there's Postgres. Again, it's an open source relational database. We've just moved on to Postgres 11. We run, as a matter of principle, the standard open source variant. So there aren't any customizations here that can lead to incompatibilities with other standard Postgres services. I'm going to skip over Connect here. We're going to save that for the end. There's Redis, again, high performance in-memory key value store. Great for caching session tokens, for managing queues. Then, of course, you have Kafka, which is a distributed high-scale message bus. So more and more being used around data integration. Connect is a fully managed data integration solution. And this is really the bridge between Salesforce and Heroku. The database is the backplane. Connect is basically the bridge, right? So what does it do? Obviously, there's a lot of sort of things, patterns and practices under the heading of data integration. The way I like to explain it is that Connect supports 2 specific data integration patterns. One is data replication, so literally move data from one place to another, keep it synchronized, right? And we support unidirectional or bi-directional replication. And then we support data virtualization, and we do that via an OData provider. And again, that's also bi-directional. What people use Connect for, I'd say 4, maybe 5 use cases. One is what we call extending CRM. And what we mean by this is you're building, let's say, a customer-facing app, a loyalty app. It could even be an employee-facing application that is deeply integrated with the data in Salesforce, right? So you're leveraging that Salesforce, the investment you've made from as a system of record for your customer data, as a central point through which you automate any number of business processes. The experience is being delivered by an application that's in Heroku. So that's one use case. The other one is around offloading complex processing. So if we go to the example again of I've got a business process in Salesforce, and at one of those steps in the business process can involve arbitrarily complex logic. Let's say you're going to do a credit check, right? Well, the credit check is something that you're probably not going to want to write, in Apex in Salesforce. It makes more sense to have an external service that does this. You'll call into it, or maybe you'll publish. You can leverage platform events as another pattern. But that service itself now can be running in Heroku, where you have a number of pretty compelling benefits, right? You can use pretty much any language you want, any sort of popular framework, libraries for that language. The environment itself scales elastically, so you're not going to basically risk performance issues inside of your CRM every time this workflow has to happen, or if it's happening at scale. So that's another great example of where you'd use Connect. Multi-org scenarios, a lot of companies have multiple sales and service orgs. And this happens from mergers and acquisitions. It happens from sort of organic adoption of Salesforce across business units. There's any number of reasons why it might happen, but typically there's a strong desire to then get a unified view. Now, obviously, and you've probably heard about the investments we're making around Customer 360 within Salesforce, and that is sort of our premier solution around that. Why people will sometimes choose to follow the pattern within Heroku and leverage Connect depends if you want sort of a broader view outside of just the customer. It can assist with that. If you're actually wanting to to integrate it with a number of other sources, let's say a non-Salesforce CRM or other line of business applications, then you can sort of use the database there as the foundation for doing that integration. Analytics and insight, I think that's self-explanatory. Again, you may be doing some arbitrarily complex modeling and calc definition, ML, any of that where you actually want to leverage the Salesforce data, and then what you may often do is expose back the result in a contextual way in Salesforce rather than pushing all that data back to Salesforce. One that's not on here that I'll mention in brief is data archiving. Heroku Connect isn't an archiving solution, but if you think about it, it's a really powerful, highly scalable engine. So we have partners who've actually built archiving solutions. And by solution, I mean when you think about sort of the user interface, you probably want that in Salesforce, defining the various rules around how the archiving is going to happen. But then they use, again, Connect as the engine for that. So quick overview of Heroku Connect Sync. Again, it's bi-directional. You can set it up to be either unidirectional or bi-directional. Massively scalable. So we have a number of customers who are now over 1 billion, in some cases 2 billion rows under management. As a service, we manage in the many billions of rows and about 18,000 instances of the service across 6 global regions. So it's been GA for 4+ years. We've put a ton of effort into making sure that that's rock solid and highly scalable. It's super easy, as you'll see. So oftentimes there's this trade around scalability and usability. That's not true here. Actually, the trade-off is really around sort of functionality. It's quite narrowly focused, but it's very easy to use and very scalable. And the power, a lot of the power I think comes from just the ubiquity of understanding SQL, right, and databases. And so you do get this kind of conceptual, right, abstraction where you don't necessarily have to be deeply familiar with Salesforce APIs, the various idiosyncrasies of different types of objects, the different APIs themselves. So this gives you a little bit of an isolation layer, which I think for a development team in particular or a data team, you can spend that time doing differentiated work. So I want to give you a high level of how it works. This is the sync engine, not the OData piece. Ideally, we operate off of system mod stamp in Salesforce. All objects don't have that system mod stamp, so we have logic to fall back to last modified, and then we have further fallback, an algorithm that sort of determines that. But what we do is we essentially, for your initial load, we leverage the bulk API, load all the data into Postgres. Subsequent to that, we will then, once the load is done, we basically have, you can think of it as a high water mark. It's basically a timestamp. Then we go and poll again, and we determine all the changes based on that timestamp. So this polling interval, as Troy will show you, is configurable, just a slider, and it can go down to 2 minutes, and it can be as high as 60 minutes, right? So if you have something that doesn't change very often, and you want to sort of save some of that polling load, you can set that number higher, and then you can also get it to be really low latency. I won't say real time. It's not a real time solution, but it's fast, typically. And the way that happens is by leveraging the streaming API. So what we can do is actually register for a push notification on an object. So instead of solely relying on, let's say, a 2-minute poll, we'll do that, and we'll do that anyways as a safeguard, but then we'll wait till we get this push notification. When we get that notification, we're like, okay, do an on-demand poll. So that's how we determine changes relative to Salesforce. Internally, we use a Postgres capability. We model triggers, and we use a capability called PG Notify, and that polling interval, or that sort of the interval through which we check, is pretty much fixed, and it's 10 seconds. And so that's how we process the write back into Salesforce when you've configured it to work that way. Reads, highly parallelized. And we don't manifest. We will bring over, primary keys, foreign keys, but we don't then define the relationships, right? So common technique you'll see in data warehouses as well. And the idea is so we can just load objects in parallel without having to worry about the dependencies. For folks here who are more technical, one of the implications there, and in general how to think of this system, is eventually consistent, right? So at any given moment in time, you might not have an exact representation. You may have, a child sort of contact might appear before you have the account. These are typically very short windows in time, but if you're going to be, to be sort of extremely, as accurate as possible, then it is very much an eventually consistent system. Conflict resolution, pretty straightforward. Last writer wins, right? So a change happens. Let's say you've got a bi-directional integration set up. The assumption is, design assumption here is Salesforce is the system of record in the context of sync. So we don't own that relationship. We don't own those objects. We may be a channel, a conduit, through which updates get made to any number of Salesforce objects, but there's who knows how many other sort of consumers out there who may be editing. And so that's sort of how to think about how that piece works. So the data virtualization piece is enabled via the OData 4.0 standard, right? And much like sync, it's bi-directional. It can be far more efficient for some use cases, right? So if you think of, sometimes I joke and I say, the worst thing you can do is think of Salesforce as a giant database, right? Like you don't want to put all of your, indiscriminately put all the data in your CRM. But there's a bunch of information that's otherwise useful contextually. So let's say in the context of Service Cloud, you may be in the business of selling connected devices or appliances. And those devices, right, will sort of generate all sorts of logs, and you'll have some strategy, through sort of edge compute and eventually uploading the stuff somewhere. And there's going to be a lot of noise there, but there's certain, some percentage of that data, some view into that data, if you will, sort of errors that are predicting a failure, warnings, I should say, or errors when a failure does occur, and you try to understand what it is so you know what sort of parts to order. All of this is a great example of something that you can actually you could put into your Postgres and then expose that virtually into Salesforce using external objects, right? And external objects behave much like native objects in Salesforce, right? You just define the data source, and Salesforce basically acts as a OData client in that case. So I could, open up Troy's customer record, and when he calls, and I'll sort of see, nice and contextually, I'll see, all the information there about his, whatever his smart device is. So again, it can be a lot more efficient, and it can be more, again, more applicable to certain use cases than synchronization. It's more or less real time. It's the latency is really sort of mostly around the complexity of the query and how long it takes to resolve that query, including the network round trip. Super simple. You're going to see this in the demo. Again, everything with Connect, I think the theme there is it's really, really easy to set up. And again, it's very powerful because of that built-in integration with Salesforce. But one thing to note is it's also implemented to an open standard, right? That's what OData is. And that means that basically any OData-aware client can consume this data as well.
Cool.
That's right.
Thanks. Yeah, thanks, Rob. Before we get started in the demo, I actually wanted to bring a real-life example to you to give you an example of how a Salesforce customer comes to us and says, help me extend a business process out here. So the customer I want to talk to you today about is a company called Meralco. Meralco are an energy supplier. They're based in the Philippines out of Manila. It's probably the second largest energy supplier, I think, inside the Philippines, country at 200, first largest, thanks GG, so updated me. One of the largest suppliers, and 300 million people in the Philippines, like a big company. They were producing a billing file. They came to us, they're a great Salesforce customer, and they said to us, we want to go to full paperless billing. Okay, we want to go all the way digital. What we do today is out of our billing system, we produce this CSV file. Every day we send that off and we get someone to print out the bills, put it in envelopes and mail it to our customers. How can we use Salesforce technology to help us out? They already had the community cloud. They already had an excellent service center in Service Cloud, and they already had Marketing Cloud. So there was a lot of assets there for us to leverage as well. And so we sort of approached them with one of our partners and said, well, how about we do this? We take that file that you're already generating today, and rather than figure out how to do it all at once, we break it into a few little services. The first thing we do is we get someone to write some custom code that simply just reads that file, and for every line, which was every individual bill, we generate a new job to process. That's all we do. And we're going to use one of those data services that Rob talked about, the Redis, as a queue in this sense. Pretty common use case of Redis if you're familiar with it. Then we're going to use another small piece of code that just takes one job at a time, generates a single file. And when it's done that, it's going to store it in an S3 bucket and use Marketing Cloud to send a notification to a user that says, come back to the community and collect your digital bill. And this was a really key part of this design. We got to close the loop in the Salesforce ecosystem. We helped Meralco drive their customers back into their community. And if you've ever implemented a community, that's one of the interesting challenges, is how do you get your customers to come back to those digital assets you put into the field and get them to engage you with you. This is a really good way to do that. What was really compelling here is that because we could say, come to your community, it was a simple flag. We put a Boolean field on the contact record. Would you like to receive a digital bill? That was it. That contact preference got synced using Heroku Connect into this Postgres database. Okay, and so now that file reader, before it generated the file, simply took that job and said, does this person want a digital bill today, right now? Okay, you talk about that use case that Rob just mentioned, that sync time is a minute, 2 minutes, it's fairly quick. That's really useful for these guys. I can go in and click digital bill and that starts straight away. I can go back into and say, I don't want my digital bills anymore and unselect it and it stops straight away. The real takeaway for Meralco here, there was 4 pieces of custom code. They sort of wrote just a little under 1,000 lines of Java code here with a partner. Okay, really simple. This was 6 weeks from, okay, we're going to kick the project off to delivery to production. And I think the kicker here for Meralco is once it was finished, their partner left the building. And that's what's really key for me about Heroku. It's a really nice platform to help you separate the implementation from the management of your platform. And that's what they got out of that as well. So I want to give you an example of how to set this up. It's a fairly simple, trivial example, but I think it definitely illustrates some of the simplicity we're talking about here. Okay, everyone relax. This is a command line.
I think you got to switch.
Oh. I'm going to create a very simple application here. I'm going to use JavaScript today. This is not a Heroku-specific thing. We speak many, many different languages here at Heroku. It just works nice and quickly. Okay. One of the really nice things about Heroku is we are completely open source. And what I mean by that is that any kind of the languages that your developers are using today, we support them. We don't make you do things like, import an SDK to make things work on Heroku. We support full 12-factor apps. And so all I need to do is tell Heroku that I'm going to run a Node app on the web. This is what I want, okay? Again, another really great example of us meeting developers where they work already. I just use Git, okay? Now, if you know what Git is, you're pretty familiar with what I'm doing here. If you don't worry about it. It's a toolkit that developers use to manage code, all right? It's one of those black box things that your developers do. Okay, you haven't seen anything that's Heroku specific, by the way. It's pretty simple. It's pretty sort of standard stuff. So let's create an application in Heroku. And as you sit there and watch me fat finger the keyboard, I'm going to go and create this application. Again, an application is just kind of like a logical place for Heroku to run assets and resources. So I need to push my code. And I'm going to use Git again to say, take the master branch and push this to the Heroku repository that we just created. And here's some of the magic. It's detected it's a JavaScript app. Okay, so it's going to push that out. It's going to build that JavaScript language environment. Heroku manages your operating system and your language runtime environment as well. Really, really simple, great security features. We run over 2 million apps today and everything's on the latest version of our operating system. Okay, nice security feature. You'll see that it's discovered that I wanted a web process and it's built and launched that for me as well. So let's go and have a look at what we just created. I'm going to use this little command. It opens up my web browser. Now this is where I get to use my really pithy little saying, we will resume normal programming. Now, the pithy little statement that I was about to make was the white space here is now your responsibility. It was worth the wait. So let's have a look at what we did. This is the Heroku dashboard. For everyone that was just sweating, the command line stuff's over. It's cool. You'll see that I've just created my application here, the Dreamforce demo app. Now, if you're familiar with the Salesforce licensing model, you're probably familiar with this idea of a user-based license. Heroku is pretty different. Heroku is resource-based. Okay, and what that means is that if you wanted to build an application that had 1 million users, if you could do that with 2 dynos or 2 computers, fine, go ahead, do that. We're going to charge you for 2 computers. It's a sort of a different kind of model. And so when we talk about resources, it's pretty simple. If you're familiar with the AWS licensing model, you'll know that it's a little bit more complicated, right? Anyway, it's complicated. With Heroku, it's data and it's compute. And that's it. And so what do I mean by that? Compute, we talk about this thing called a dyno. A dyno is a container, if you're familiar with that term. So the containers didn't really exist when Heroku started, so we called it a dyno. It's a much higher abstraction than some of the things you're going to see in Docker as well, which is kind of useful. So we could select a container. I can scale vertically. This is really useful. I'm going to deliver an app. Maybe it's small, maybe it's large, whatever. I can scale horizontally again. And this is truly elastic compute. I might want 30 of those for the next 20 minutes. I'm going to run an ad in the Super Bowl. Right? Halftime at the Super Bowl, let's spin it up. I need to go. Okay, the game's back on, let's spin it back down. Don't need it anymore. Really useful stuff. Then we can start to look at some of the data services. And here's how we start to add those services to this application. And so these are the data services that Rod was talking about. Kafka, Postgres, Redis. So let's add a database on. Again, as a developer, super simple for me. I don't need to be a database expert. This is pretty easy. I choose what size I want to do, and I provision that database. I get back to writing my code. This is what Heroku is really good at. Get my developers back writing my code, delivering features to my users. Say that I didn't want one of those things. I might want a third-party kind of application. I want to capture some application logs, for example. There's a bunch of logging services. Today I'm going to add Papertrail for no other reason that it's there. So now I'm going to add some third-party logging services. We do this with things like search databases. We do this with queuing services, monitoring services. There's over 200 different add-ons here that you can take advantage of as a developer. Of course, we're here to talk about Heroku Connect. So let's add on the Heroku Connect service and have a look at what we're going to do. So now I'm provisioning this service that is going to synchronize data from Salesforce into this Postgres database that I've just created. I'm going to use this Salesforce instance here. This is my Salesforce account, the Salesforce we know and love, okay? So let's connect these two things together. I'm going to jump over and go to my Heroku Connect dashboard. You'll notice in Heroku there's a couple of different dashboards. You've got one for data services, you've got your Connect dashboard, you've got your compute dashboard. Really easy for users. This is my filler as we do the single sign-on, by the way. Here is the Connect dashboard. So the first thing I need to do is authenticate it to Salesforce, right? Heroku Connect, everyone, is just an API client. If you're familiar with writing things to the Salesforce API, all those best practices that we talk about are exactly the same. Would you put your Salesforce admin credentials into an API client, right? No, you want an integration user. Those are the things, they apply here as well. We'll talk a little bit about as we get towards the end about why we think this is a good choice for you. But as a standard API client does, I just select what version of the API I want to run, log in to my org. Away I go. And now I'm ready to start synchronizing different objects. Okay, first thing to talk about Connect. You are not going to sync every single object inside Salesforce. There is a lot of objects in Salesforce that make no sense outside of Salesforce. System tables and things like that, right? So it doesn't make much sense. But what you want to do is start to think about which objects you might choose. Let's go back to that Meralco kind of example. They wanted the contact object. They actually had some customer preferences objects inside a data model there as well. And this is where the first time sometimes people get surprised, because my account objects are here, my contact objects here, my lead, my case, my opportunity record. All those things that when I initially think about Salesforce, I've been told I need a CRM license to access. I can sync those things. Okay, it's kind of interesting. So let's have a look. Here's my contact record. This is obviously metadata aware, so it's going to get all the custom fields that I have on that contact record. Okay, and it's going to take those things, and it allows me to do things like set my polling frequency. I'm just on the demo version. By the way, you can all walk out of here today, connect the demo version of Heroku Connect to your Salesforce instance and try this out. Okay, we've got free tiers for everyone. If you've got the paid tier, you can get this down to the 2 minutes that Rob was talking about. Or I can use the streaming API, and I can write data back to Salesforce. Okay, so I can update this Postgres database and write it back. Again, let's make that a little bit bigger. Here's what I'm going to start to do. I might want to sync the email. I might want to sync my name. Let's say my last name. And I know that I'm actually going to build a search service on the last name, so I'm going to index this inside the Postgres database as well for search performance. Okay, so I get some of those features here that's really nice and easy for me to set up and run. So I'm going to save that mapping, and away I go. And you see that it says there's 8 fields. There is 108 and 108 rows now in my Postgres database. And that's it. Now I've set up this connection that those two data sources are going to be connected in sync. Okay? No matter how often you change either of those sides, by the way. There can be a really chatty interface, it's fine. One of the nice advantages of Heroku Connect over building this yourself is that we don't meter the API on Salesforce. This is a Salesforce product, so this does not count towards your API limits inside Salesforce, okay? Look, the common reason that I see customers do this is not to get around API limits, to be super honest. The real reason that this becomes advantageous is when you're doing high volume reads that really require a lot of performance. If you're building things where milliseconds matters, you want direct access to that database. A lot of customers I talk to just simply want a JDBC connectivity to a database. There's a really nice feature on the Postgres private service that allows you to expose that Postgres database as a private link directly in a VPC of yours, for those that are Amazon customers in the room as well. Yeah, sure, shoot me. I'm sorry, can you just use the mic? Is that question mic on, guys? Yeah.
Thank you. My question is, all the API calls that you are making to the Salesforce,
Yep.
is it counted against my API quota?
No, it's not.
Nope.
Got a comment?
Yeah, we're whitelisted for bulk API, streaming API, SOAP, and REST. So none of the calls that the Connect service makes on your behalf, and technically on behalf of the integration user, right? But there's a connected app that's registered there. It's all whitelisted. None of it counts against your limit.
Thank you.
Sure.
So let's talk about something that I think is important for a second. I want to just jump through some of these other tabs here. The thing I really want to point out is this thing here that says Salesforce Errors. By way of show of hands, has anyone used the Salesforce API before? Excellent. Okay, so there's a few conditions that when you write data to the API that you have to handle, right? Some users got a record open for lock. It's a pretty common one, okay? Workflows fire and rolls back transactions, things like that, right? You can get errors when you write to the API. This is an API client, it's no different. Okay. The nice thing about Heroku Connect is if you build applications on top of the data here, your end user doesn't see that error. It really helps you to decouple that application from your Salesforce data schema. And I know there's no Salesforce admin in the room that would ever go and change a field label that would break an integration. That never happens, right? But in the theoretical world where it may happen, this actually protects you a little bit from this. All that Heroku does is your synchronization stops. You get that notification as the admin for Heroku Connect, but your end user gets to continue to transact on the database. And it's a little bit nicer experience than trying to get your frontline service desk understand what could not obtain write lock means when they try and write to an API. So the thing I also like to point out about here is the only thing you've brought across is your data. I sort of mentioned you can sync any object you want, and I can guarantee you there was at least one people in the room that's like, I can build stuff on cases. I don't need Service Cloud, right? It's a pretty common conversation that I have, and if that's the thought that you had, I just want you to go and read the documentation about what Service Cloud can do. Because if you think that Salesforce is just a database, as Rob said, then I think you've not grasped what Salesforce is good about. Give you an example of things that don't come across here. Profile, role hierarchy, like sharing rules, data access. That's a big thing for a lot of customers. Workflows, field validations, right? All these things could show up here as Salesforce errors, okay? So I would really encourage you that this is a great piece of kit to have in your toolbox, but understand the use case that you're going to deploy it for, because personally, and we're in personal opinion territory now, I don't want to rebuild Salesforce as a developer. You might, and more power to you. Here's the data we've just heard. Here's a good example. Here's Wes Chopper. If you wanted to go in and have a look at the data, there's an Explorer tool here as well. We touched on this thing that Heroku Connect can also expose OData records. And I see customers do this a lot. They use this Postgres as a staging area for data that comes from internal to their organization. You can connect to a private service especially, really nice here, and expose that into your Salesforce world. Perhaps even do some first level transformation here. Okay, you want to start to get the lifetime value of customer and things like that. That's a pretty common one. And again, you can just create some credentials, and now you've got a named credential to put in Salesforce, and you have that external object access there as well. So if you're looking for the other end of your OData connection, Heroku Connect can be that point and click service for you as well. I wanted to just sort of touch on some of the settings here as well, because I think it's fairly important if you want to come in and manage this service. You'll see here we've just connected. We've got this label. We're in Virginia at the moment. We run in all the different regions that we support Heroku around the world. So if you're here from Europe or Asia, we absolutely have got you covered in those regions there as well. Rob, one of the things I've got to be honest, man, I've written APIs against Salesforce for like 10 years. What's the difference here? Ordered rights, merged rights, why do I care?
Yeah, that's a great question. So when we first built Connect, this was before the days of whitelisted API calls. So minimizing the number of calls we made was actually an important design goal. And we did that by essentially having this merged rights algorithm that would look at, within Postgres, all the pending rights to Salesforce and try to coalesce them. You almost think of it as bin packing, right? To get the maximum density in each API call that we would make. And it worked really well for its purpose. It works well today. It's still supported. But over time, especially as we had whitelisted API calls, there was more flexibility there, and we came up with a new algorithm, chiefly for two reasons. One, just semantic understanding. It's really easy to sort of process sort of the rights are going to basically, we're going to treat this log of pending rights as a strict execution order. And so the order in which you or your app wrote a change, let's say it's an update to a record, is the order in which it'll get processed. So it gives you very kind of a transparent, clear model for how it's going to execute.
Cool.
The second thing it did, just in brief, is it allowed us to implement bulk rights. So the Connect will automatically go into bulk rights mode if a few conditions are met, but I would say the chief condition there is just a certain number of contiguous rights of the same type to the same object. So you make 5,000 inserts into a contact object, we'll detect where it's above our bulk threshold, and then we'll use the bulk API.
Cool. So it really abstracts some of the complexity of the API for me. That's nice. That's really nice. Some other things that I like here is obviously the ability to detect orphaned mappings, and you can get, it's metadata aware on the Salesforce side, which is really nice as well. And if you're in the room and you've got a compliance hat on, audit trails about who's doing what here are available as well. So super useful tool. Again, like definitely come and talk to us about what kind of use cases you'd like to solve with it. Really useful stuff for Heroku, but we'll flip back and we can close out.
Thank you for that great demo. Are you able to? So we only had a couple minutes, but I just want to, a common question you may be asking yourself this today. I have a team of people who write code. I'm excellent at writing code myself. You use public APIs. Why shouldn't I do this? Or why shouldn't I use one of the 3 data integration tools that my company has? And the way I would say is, to think about Connect is not as a replacement for any of those. It's more of an accelerator. It's about, again, time to value. It's about sort of the trade-off you would make between focusing on differentiated versus fundamentally sort of undifferentiated work. And beyond that, there's a certain set of things that Connect does that, again, you can imagine, 4+ years later, there's a lot of intelligence built into it. So what we talked about, the API calls, and that can be a minor commercial benefit, frankly. Relationship intelligence is when we understand the data model. It's another way of saying we understand the Salesforce data model in depth. We're part of the Salesforce platform. As the API versions get upgraded, as new objects are introduced, as behaviors change, we keep up with that. And so it's basically always up to date. Maintenance windows, or any other occurrence where Salesforce is unavailable, the system will automatically queue any pending rights. As soon as the connectivity is restored, it will then flush the queue, right? So you don't have to write any kind of error handling code to deal with that. We talked about use of APIs. You saw that we reduce latency by using the streaming API. We do initial loads or any other sort of large sort of insert situation that we detect. We'll automatically switch to using the bulk API. And likewise, when we write data, the system automatically, just without any sort of interference from you or instruction, will cycle between the different APIs. Error handling, you got a bit of a taste of that. There's a lot of work that's been sort of put into the error handling and exposing error messages. When you have write errors, we'll give you a daily digest of those. We will detect when the schema changes on either side in a way that impacts your integration, right? So if a data type is changed in Salesforce, or a field is deleted, or likewise you make a breaking change on the Postgres side, we'll detect that because we snapshot everything at creation time, and you'll get an email saying, hey, this is what changed. And it'll tell you very, very specifically what changed and what the nature of the change was. In one specific case, what we will do is we will actually automatically change the data type. If we can, if it's compatible and allows us to do it, we'll go ahead and increase it for you. And of course, you get 24/7 support. So, you know, we only have about a minute here, so I'm just gonna, unfortunately, gonna have to skip a couple of slides, and I apologize for that. Best thing to do here, probably, I just want to point you to a few other Heroku sessions that are coming up. You'll have access to these slides. And thank you for your time. I appreciate it. And speaking for Troy, he does very much. And we'll stick around, probably outside, for any questions you might have.
Thanks, everyone.
Thank you.